Okay, we're now going to look quickly at two of the most basic operations we can perform on processes. The first one, process creation, is very basic. When we create a child process from a parent process, we call that forking. So processes in most systems, and specifically in Linux systems, which is what we are dealing with in this course, are stored in a tree hierarchy. So there is a parent, the parent has children, they again have children, and so on. So that's it about process creation. We're not going too much into the depths of it. Process termination, on the other hand, we'll be looking at a little more of the technicality. So before we go into the nuances of process termination, we'll look at what is cascading termination. So the idea is, when you terminate a parent process, all its children must be terminated. So if you are familiar with your data structures course, where you would have studied about trees, you will know that one of the general ways in which deletion in a tree data structure happens is, when you delete a parent node, its children must also be deleted. So when you delete this bash node here, its children ps and bim will also be deleted first, and then bash is deleted. Of course, in a tree data structure, there are other ways. You can probably take this ps and directly make it a child of this one, and so on. In the context of processes, that might not always make sense. So we follow the logic of cascading termination. When you want a parent to terminate, it will first ask its children to terminate, the children will ask their children to terminate, so on and so forth, until the leaf node. The leaf nodes will first terminate, then the previous, and it comes back until the specific process you wanted finally terminates itself. This thing is called cascading termination. Now, how does a parent process know that the child has terminated? It is by something called the wait system call. So let's say this bash wants to terminate itself. It will first ask its children ps and vim to terminate themselves. Now once they have terminated, they have to let bash know that they are over, right? That is when the bash will go ahead and finally terminate itself. So that happens through something called a wait system call. So the bash will ask ps and vim to terminate. Then it will give out a wait system call. Once ps and vim have terminated, they will respond to that call with something called an exit status. The bash will identify that its children have terminated, so bash will go ahead and terminate itself, and so on. So wait system call is when a parent wants a child process to terminate, and it wants to find out whether the child process has terminated or not. It issues something called the wait system call. Now, there are a couple of things that can go wrong with this wait system call, which are like boundary conditions sort of. The first one is zombie process. A process that has terminated, but its parent has not yet issued the wait system call to come to know about this termination. So we'll go back to the same example. Bash has asked its children ps and vim to terminate, and then bash does not issue the wait system call. So now ps will terminate itself, but it cannot communicate to bash that it has been terminated because the wait system call was not issued. So bash just keeps waiting indefinitely, hoping that ps will terminate itself. So in such cases, ps is called the zombie process. Please note that it is the child which has terminated itself but is unable to communicate to the parent about this termination because the parent has not issued wait system call. The child process is called a zombie process. On the other hand, we have something called the orphan process, where the parent terminated directly without invoking wait. So if bash directly terminates without asking these two to terminate themselves first. So if the order of cascading termination is violated for some reason and bash terminates itself, these two will be stranded, right? They are not linked with anything else in the tree, so they are like lone nodes there. So they are called orphan processes. So these are just some technical terms which we need to be aware of.